Ooh, Mina. Oh, that's right. Duh.
Tim, you got to explain all the devices first before you go into the software.
That sounds like a good idea.
Yeah.
Should have hit this.
A bunch of hardware and some wires, right?
It's all fake. It's all fake hardware. It just looks good though. We were joking about the connectivity, and I don't have my plug here. Too many different connectivities now. Let's see if this works. You have more machines here. Let's see if this works. So what we have here is, because of NVIDIA being in the building and being cool people, I have an NVIDIA Jetson Nano, which is a $99 IoT device that has a 128 core GPU in there. That's why you got this monster heatsink on there. This room is a little unhappily hot. I should have brought my fan. The only flaw with this device is it doesn't have a built-in Wi-Fi. Hence why I have this little guy over here. I should have used a smaller one, but it's good to show it. I brought a little screen and a thing, just trying to find the right network here is harder than it seems. Because I have a network that's on there, network on my phone, network on the laptop, and I'm trying to get to stuff in the cloud, things running on my laptop, things running on this little box. So it's a lot of funny. A lot of fun there. The reason why my cat's in there, unrelated to the Jetson Nano, his name is Nano. So I'm like, he's going to get some credit for being in the demonstration. I'm not going to go too much through the slides. I'm going to try to go through them really fast because you're running a little late. I posted these already on SlideShare and linked them in the Meetup group. We could send out an email notification if you want to look a little more. Pretty much what we talked about already with the cloud, but it doesn't really matter for us. You know, whether it's a cloud server, I happen to be running on Amazon, could be Google, could be Azure, could be IBM, could be all on premise, could be all be in the same room. You know, right here I could be happy having this device talk to the laptop and have a nice IoT setup there. Like, especially if you were, say you were running an office and you want to have, we could put a Minify agent on every desktop, and that could run PCAP to analyze people's security, run different security analytics on their device, see, you know, how much hard drive space they have, if they have any viruses, or run some Bitcoin calculations when they're sleeping, trying to make us some money on the side. You know, whatever you might run, we can run pretty much whatever we want. Minify, again, is a small open source component on here. And that could also run, like we said, in Kubernetes and a Docker container. So the edge might be to you, the edge of your cloud network. Or maybe a shared cloud network between two companies, who will go into some interesting things with blockchain where you can really start interacting between companies. And Minify might be a component very important for that, because you could easily deploy this, have it managed and monitored remotely, run some analytics, grab some data, and then go away with very little time, and do that elastically. And I'll show you some demos. We have a new tool out there that really makes IoT easy, and I'll show you the actual tool. It's our Edge Manager. This comes free when you get a license for our agents, and this lets you deploy out, you know, one agent in my case, or tens of thousands. We have a company in India that's putting this on every single gas station, and it's in every little pump. And it says if someone's trying to hack those pumps, how much fuel they're processing, if they're leaking, you know, if they're on fire, all those kind of fun things you might want to know. Again, another place you can integrate with the blockchain. We have a couple ways to do this because originally we took Minify, cut the UI off it, made it a little smaller, but then people told us I want to run on not this expensive $100 device. I want to run on a $20 device because I might have 50,000 of them. Make it a little smaller, so we've got a C++ version, a little faster. It also has a feature I really like, is these native Python processors. So you can run any of those Python scripts that you want. It runs it in the same C++ space, runs really fast. I'm not showing out to something, letting it run, come back. It can run the Python natively within the C++ engine really fast. Generally, we're not going to have Minify running on these $1 devices you might get with Arduino that doesn't have an OS. We need an OS. Makes more sense like one of these Dell Gateway boxes. Sits in your office, sits in your store, sits in your warehouse, collects data, but also can do processing, which is something very different than traditional IoT where you get some dumb box is just grabbing stuff, pushing it, and pushing a lot of data that maybe isn't of any value. We could check that data on the edge to say, this is just a heartbeat. I don't need to propagate this up and pay network fees. I'm just going to process that locally, run machine learning locally, connect to Kafka. For mine, I'm showing you I can push right to Kafka. So I'm pushing from this device through the Wi-Fi up to Kafka and Amazon. So I could push right to Kafka if that's something important to you, or I could push it through our native SSL, or I could push it to an MQTT local IoT network. We got a lot of features there. I'm going to run through these quick so we could show you the real code. Again, this is all available online, so you have these slides. This one's a little more specific to the actual device I'm running here. We're bringing it in. I'm running TensorFlow on that device, plus I'm grabbing some sensor data, plus I'm grabbing images. Minify doesn't care if something's structured data, unstructured. So I have images. I can capture audio. I can capture video, text, streaming text, JSON, XML, Avro, whatever kind of data you have. Push this in there. Minify's processing it. Push it to Kafka. Like Kafka Streams or Flink or Spark, any of these really powerful engines process it. One set of, like you mentioned, one set of governance, management, all that across a whole platform, and not just your servers on these little devices. Now, everything in the world is part of your ecosystem, so you know what happens. You could secure it. I can encrypt data from the second it's born until it's stored, and it can never be decrypted if you want it to be, even when it comes back for a query. I have some military clients that this is important, that no one ever sees that data. There's a cat. He has a little taco. I figured that will make the slides blow up on the internet. We could store it anywhere. As part of our new environment, we're going to have a lot of different storage options. I can push to S3, any of those cloud buckets. I'm also pushing to HDFS for ORC and Hive. Also pushing to Kudu, push to HBase. Anywhere you want your data to go. It's very easy for me to do that in a very quick manner. Even if the data looks kind of ugly, when I'm done with it, here's some of the data. Pretty easy to do. And I could push it to Slack. I could push it to Hue, which is our free analytics tool. I can push it to Zeppelin. I can push it to any of those graphics or reporting packages that you have already. And I can connect and run machine learning and deep learning a bunch of different ways. Like I mentioned already, I'm running pre-trained models on my edge device. I can run them within Minify as they're processing. I can also integrate with CDSW, so that will run my machine learning models that I've built within that environment. I can run them in Spark. I can run them in Flink. I can run them in Kafka. I have pretty much every part of the entire chain. I can run machine learning and deep learning models. And there's different locations for different reasons, depending on what you need. But the fact that I can run a classification on the edge So I could do things like figuring out when this is overheating. Maybe I need to turn on a fan. Maybe I need to alert someone in a building or shut down a device. I could do that right on the edge. I don't have to call out to some 50 cents a call, Amazon or Google class to do this. I can run that natively right on that box, which is very nice. Part of the Minify thing is I could build tables automatically. So I could build tables for Hive. I could build tables for Impala and Kudu. I'm building them for Parquet and Spark. All that is very easy. I've got detailed articles to show you, how do you do this in the real world down deep. And it's pretty straightforward. This is Edge Flow Manager. This lets me develop those IoT flows. And as you see here, it's doing a couple different things. I'm running classification against a model. I'm grabbing images. I'm tailing a file that I have a sensor pushing to, grabbing all this data. And I'm not just pushing it to Minify through SSL. I'm also pushing it to MQTT and to Kafka. And I can push it to as many different things as I want. What's nice here is what you're seeing here is a bunch of different IoT classes. And a class is a way to group together your different IoT functionality. So each one of these classes could have 10,000 devices I push to. And when I finish changing a flow, say like this one, I make a change, with what I'm doing here. This one I'm filtering out errors. Maybe I want to do something different to this. Maybe I want to call a model. When I'm done, when I do publish, it's not just sending this out to our version control registry. It's sending it out to every device of this class. And that could be a lot of them. In one place, you're managing all those devices. When it comes back, I get the heartbeat and the status of all those devices, how they got deployed. In a new release coming out in a few days, we have a more graphical environment. It hooked up with Prometheus and Grafana, if you know monitoring. That will show you the incredible dashboards of where all these devices are in the world, what's their status, are they on the latest version, are some offline, those sort of things. Everything you see has a REST API behind it. So any data you want to integrate with your existing monitoring platforms or DevOps tools, very easy to plug into this. Makes it for a pretty easy environment to work with. So we did all that. It pushed it out to this device and any device of that class. From there, we have it calling Minify. Minify is getting the data a couple different ways. I'm consuming that Kafka flow as it comes in. What's nice is it doesn't matter what that data is. It just comes in. I'm reading it. I send it off to a converter. I know this one's JSON. I do conversion from JSON to Avro, either automatically inferring that schema by looking at it or grabbing it from our schema registry. And because I have a schema, I know all the fields and all the field types. So now I can run any SQL I want on that. So that's aggregates, that's order bys, group bys, I'm casting. So I can use this to convert the data from JSON to Avro only for these specific ones I want. And I can run as many queries in there as I want. And the result of each one can do something different. So I'm able to route with SQL, convert the data with SQL, write no code, support any schema, any version of the schema. That's all my code. That could take 10,000 different IoT flows that have JSON coming in and run a query on them and then process that data. And as you see here, I'm taking that, pushing it to Kudu with an Impala table on that. That's a very fast way of pushing in data like this that's time series. And now I instantly have that data available for querying. I'm not waiting around. As data comes in, I get more of it here. I can run it in my cloud data warehouse or data mart, use that and join that with other sources of data. Very straightforward to do. And here is, again, part of everything that's under CDP. I'm running this in CDH 6.3, which is a very recent version. Pretty soon I'm going to upgrade this to CDP. It won't be much different other than I can auto scale everything in here. But here I have one platform running streaming, running the storage, Spark, everything I need in one place. Data getting pushed to things like Slack. I push it to these Impala tables. I also have, in here I have some Hive tables, because I can push it to, if you look over here, I'm also pushing it to HDFS. I'm putting it as ORC files. ORC is the native format for Hive 3. So right now I can instantly push to an ACID table. So I could either have it in ACID or Kudu. You see I'm pushing them at the same time. So you can make your decisions what table works better for you. Or you might have reasons why you want it in one table format or another. Maybe one is always doing updates. One just keeps, every single historical record that ever happened. So, as a new record comes in, I just keep appending. Or you want to do updates, depends on what makes sense for you. I might need to push this to another data store for someone else to use. Again, it's very easy for me to take this data, regardless of what it is, and just publish it to Kafka and do some other processing. We were saying, how do I integrate machine learning? Already did it on the edge. I already did it in Minify over here because we have some native processors here for doing TensorFlow and for doing Apache MXNet on images. And there's ones for doing sentiment analysis and some other ones. It's a very simple API. You could just drop your things in there. I'm working with H2O on putting their platform in here. So it'd be very easy to integrate their models. We'll probably have that in a future meetup. But we have our own ways of doing machine learning. So with this simple call, as JSON comes in, I'm going to look for a field here. When I get that field, I'm going to make a REST call out. That REST call is going into this prediction model, gets that data from that record, gives me a prediction back. So what it's doing is I have a machine learning model here that does time series analysis based on this sensor data. And it's really looking for trends where things are out of bounds. It's doing standard random forest, pretty simple machine learning, but useful for things like time series. What's nice is this is trivial to implement. There's no handwriting code. I didn't deploy or write complex Spark. I had the model, the data scientist worked on it, pressed a button, deployed it in his environment. This is me integrating it to a real-time ELT flow. As the data comes in, I do the lookup. I do an update record with that data. Now I've taken the result of that prediction and I've added that to my record real-time in stream. Now it has another flag in it. I write that to Kudu. What table is that? Let's see, sensors 2. Go to Hue. Let's take a look at sensor 2 data. Oh, we don't have system time. This is a different looking field. So what we've done is it looked at this, it analyzed these fields, it gave me a health indicator to say this data looks healthy based on previous trends, based on ranges, all that kind of fun stuff data scientists like to figure out with all those features. That's a little above my pay grade. So other people do that and get lots of money. I get to learn that one day. We all should go to that meetup, learn how to do this stuff. But that's a lot of work. But all I know is this is how easy it was for me to integrate that in a real-time flow, use that model, and also while I'm doing this, I'm calling that data, putting it into a permanent store, and in the background I have a CDSW experiment running that's retraining the model. So it's getting better each time we do this. It's learning from more data. This is your whole environment. Everything's secured, single sign-on, one place to do this. This is a simple model we teach in a class. This is not It took some IT firm 6 months to write this. You go up to Boston in like 2 weeks. We'll lead you through a class on doing this, and it's literally that easy to real time classify against the model, train the model, update your data within the stream. All of it graphical, all of it scalable out to 15 petabytes a day without a blink. I've got a couple people who are thinking to push it into the 100 petabyte a day range. That one, we're going to see how that goes. 15 petabytes is pretty nice range for us now. So do that real time in the stream, update in the storage. Doesn't matter where it's running. This is running on a one node Amazon cluster. It's doing all that processing, plus running Kafka, Minify, Kudu, all the admin tools. Obviously, that can be done with CDP, scale out automatically as your workloads go up. Very easy to integrate from data science part. Here, and you also get the monitoring in there. This is run 11,000 times. Or is that more than 11,000? No, it's 100,000. I guess I've left this running. So this has been running 100,000 times. It's been running. Ooh, it worked every time. That doesn't happen. I'm pretty impressed with this model. My models usually fail because they take up too much memory. But this model is constantly running, classifying against this data as it's coming in. This is sensor data coming into the system, being checked. This is constantly happening so we can update, add that health field. And that could be anything you need it to be. You have something that detects fraud in credit cards. You detect, I have some ATM users in Asia. Again, they're looking, does this look normal, this flow from these machines? Did it take a little longer than it should? Let's start raising those flags, and we can automatically push out alerts to people and do that real time. The problem we had before was I could do that. Sure, that's pretty easy, right? Real time streaming, machine learning, IoT, all that. But how do I know what it's really doing? What happens? This is so many potential machines. This could be thousands of machines over 3 clouds. How do I know where my messages are? Where are things slowing down? How do I do that? We added that because people are saying, I can't figure out what's going on. How do I know what's happening in something like Kafka? Really complex messaging system. We added a graphical tool that lets you watch all these messages as they come in, see who's lagging, who has issues. I can create real-time alerts for anyone to see, okay, if this particular topic, if this particular consumer is a little late, someone should get notified. That means maybe an app is down, it's not meeting our needs. Very straightforward for us to do those kind of things. Full monitoring. And then someone told me, that's nice and all. Maybe what do you support with that? A few 100 million records a second? I have 7 data centers across the world. How do I keep them all in sync real time? That's really hard. So we wrote a new system to do that. It's also in the open source. It's called MirrorMaker 2 for Apache Kafka. This lets you replicate between any number of Kafka clusters, active, nothing you need to do. You type in what clusters you want this on, press go. And if you want any topics list not involved, you put a blacklist saying don't do these topics. You don't have to rename things. You don't have to do special coding. It'll just keep those in sync active. If a cluster goes down, no one is affected. We'll send alerts to tell people restart that one. Messages all go through the other one. All consumers and producers automatically point to the right place. And all that's done automatically. And we put this into the Apache Kafka. This will be released officially for the Kafka in the 2.4 release. We already have a GUI on top of it. Does everything you need to do, no matter how big this workload is. No matter how many different data centers or clouds or how many things you have to spread across. Fully monitored and managed. Solve that security we talked about. SDX, everything in one place. No matter how much data, wherever it's going. So that kind of nice features in this little demo. Again, it'd be nice if I had another cluster on the other part of the world I could do that for. We do that in the workshop, though. We show you replicating between Paris and New York. And while you're pushing messages to one, they show up in both places. They keep them in sync. Offsets are maintained. So it's not just messages. It's metadata. It's all the data you need on the other side. So if I create a new topic here, it shows up instantly in all the other clusters it needs to. Messages start routing where they need to. Offsets are maintained. So if I'm consuming, I'm at message 27, server goes down, I'm at message 27, I don't lose anything. I could still go back nice in Kafka. I could go back as big as a queue as I want to keep it. Most people keep 7 days. So I could go back and reprocess stuff from 7 days. All maintained for you. You don't have to do much work. Which to me is nice, because this stuff before was hard. You know, just doing a simple IoT app meant I roll my own gateway, develop my own agents. You know, how do I manage and monitor that? How do I secure it? Everything was hand done. I did this for a startup up Central Jersey for real-time energy monitoring. It took us 2 years to do that. I have an article where I wrote it in an hour, and it'll do the same thing that we spent 2 years writing with 3 guys, and we worked on that full time. All the open source tools are there for you now. Makes it very easy. And what's nice is it doesn't just do this. We're going to show you in a minute how you can integrate with the blockchain to do even more and expand out to pretty much any kind of data application you want to do. So I think we're getting low on time. So let's move over to Mahul here.
Hey, can I have a quick question?
Sure.
So, Minify and Kubernetes